Hi, it's Mike Barnes here again, looking to talk to you about the demand for electricity. Aside from greenhouse gases and the consequences of global warming, and also the depletion of fossil fuels at these unsustainable levels, I mean, after all, whether it's coal or oil or natural gas, there's only about 150 years worth of that stuff left, scientists predict. What's the real problem driving the renewable energy market? I mean, why would we ever want to incentivize folks to install renewable energy solutions like solar PV in the first place? Well, it really all has to do with this concept of the demand for electricity. Let me explain. I'm showing a little graph here, and you can see we're starting at 3 a.m. This is kind of a rough sketch of the demand for electricity in the U.S. market. And to describe this, except for teenagers and college students, most folks sleep from around 11 p.m. to around 6 a.m. And so during this time, it's our lowest point of usage for electricity on the grid. And I can draw a little line here and show that anything below this dotted line we might consider to be what I would call base load of electricity. Oops, there's the O. So here's our base load of electricity. It's always running, and we can think of that as being the cheapest possible number out there. By cheap, we're measuring electricity in terms of cents per kilowatt hour. And we might write down that our base load electricity, electricity that we're only demanding between about 11 p.m. and let's call it you can see I've got the graph going up here at 6 a.m. but let's draw a little line here from about here to here. Let's call that number around, say, 6 cents per kilowatt hour. Okay, so electricity during this time is fairly cheap because we're not demanding a lot of it. If we were buying, and this goes directly against the way you normally get discounted breaks in purchasing large items, I often use this analogy. If the class were buying, each of us in this class were buying a single football, I mean, we might pay, I don't know what, 20 bucks for a football out there. But if we were buying truckloads of footballs, we certainly wouldn't be paying $20 a piece. We'd probably be paying something on the order of, let's say it's half that, $10 a piece. And if we were buying trainloads of footballs, you might be paying on the order of, well, I don't even know, it might be something like $3 or $4 per football. Not so when we are demanding electricity. The reason being, this base load that we have, you've got these coal plants out there that are producing most of the base load in the U.S. Actually, that's shifting over to natural gas now that the Marcellus shale find has happened. But let's just refer to this primarily as coal. And those coal plants, they don't start instantly. They take a little bit of time to fire up, and so they're really kind of running around the clock producing base load electricity. Again, I'm saying too that this is changing somewhat to natural gas as well. We'll just put a little natural gas symbol up here as well. Actually, last year, natural gas and coal are kind of tied 50-50 in how much they're contributing to this base load of electricity. So then, going back to as we're waking up in the morning, getting ready for work or school or what have you, you're hopping in the shower, you start using up electricity, whether it's making breakfast or turning on your microwave, making coffee, using your hair dryer and so forth. And so this load starts to ramp up. Our demand for electricity, for using more electricity, continues to increase. And it increases throughout the day because even when you leave for work or school or whatever, in this little segment here, you still have stuff pretty much running, demanding electricity in two places, at home and at work now. Your hot water heater, if it's electric, continues to run in order to replenish the hot water you use for your shower. But at the same time, you get into your work or school or office and you're firing up lights. You may be getting another snack there. And so this really starts to ramp up. It continues to ramp up throughout the morning and to the noon hour, primarily based on the fact that it's getting hotter. So up here where it's getting hot during midday, you really have a high demand for electricity because you have a high demand for, and I'll go back to the blue here, for air conditioning load. So that large air conditioning load really contributes to this spike in demand that's seen here throughout the middle and the latter portion of the day. The curve comes back down here, you can see, as we get off of school, get home from work, and so on. We get home, and again, another little hiccup, another little demand curve happens here, because as we're getting home, folks are again firing up stuff at their house to make dinners. They're turning on televisions. They may be getting showers again. And so you have, again, usage for, or demand for electricity happening both at work and at your home again. So there's a little blip here, and as more people, of course, get home and start peeling off of work, finally factories and that shut down, except for those, of course, running 24 hours a day. But think of your school or university, it shuts down most of their load at night. Temperatures revert to moderate levels, and we're back down here at this cheaper electricity price of about 6 cents a kilowatt hour. Now, the problem is not so much our base load. If we were able to generate electricity and pay 6 cents per kilowatt hour, now this is on the retail level, I should make a note of that, then we would also note that during times of high demand, this peak demand here, we could be paying as high as, or that electricity could be costing as much as, upwards to, let's call it 27 cents per kilowatt hour. Far cry from the 6 cents down here. And we recognize as a country that we are still going to need that base load of electricity. The real problem is this big demand hump here. And this is the real driver for renewables. We know that without some serious science, it's going to be hard to eliminate this hump, although certainly some things have, and any sort of technologies that try and move this hump so that it occurs someplace else, electricity actually would get cheaper, unlike our little example up here with the footballs. Demanding more electricity actually results in more expense. Now, you might think, well, why is that? Why is it more expensive as we demand more electricity? It's not that way with footballs. And the reason is because if, as a group, we had 3 different plants that we had invested in. Let's say over here we bought as a class, we became a utility, and we bought a couple of nuclear plants. And then over here we decided that we would have buy or purchase interest in a dam for electricity generation. And so we've got a hydro station here. And then finally over here, in order to meet this peak demand hump up here, we decided, okay, well, we're going to have to own a couple of these coal-fired facilities because we really have no other option but to, during times when we have to use our dirtiest, most expensive plants, we got no choice but to bring this thing online. Now, if we were producing here in our nuclear facility electricity, let's call this at the wholesale rate 3 cents, and the hydro plant costs us 5 cents to operate, and this dirty coal facility with all the federal restrictions and so forth now cost us 7 cents, and now this is at the wholesale level. At the wholesale level, then we would never ever let the nuclear facility go offline, because the nuclear facility is costing us the least to operate. In fact, if we were to take that offline at any point in time, we would want to have a scheduled outage well in advance of taking that puppy down. Because, again, as a business, a public utility, even though it's a public utility, it's still considered a business in the business of making money for their shareholders. The nuclear facility proves to be the biggest bang for the buck because we're producing electricity at the wholesale level of 3 cents. We're selling this wholesale level 3 cents back into our base load down here and charging our customers 6 cents. So you can kind of see, okay, well, this is big bang for the buck, and it doesn't hurt or impact our customer base that much where they're going to be screaming bloody murder because we're keeping our costs low. We would also use this hydro plant, and great, we might sell the hydro plant's electricity back into our medium load here. I'll just go here. Let's go with our medium level load or demand. When I'm talking about demand for electricity, I'm speaking in terms of load, which we will learn about as we delve more into the text. And let's say we have, as a group, we have our hydro plant feeding into this median level, what we're demanding for electricity, and so that's applying that amount. Finally, though, during times when it is super duper hot and everybody's got their air conditioners on and it is really roasting out here, we have no choice but to bring this coal plant, which may be the most expensive form, online in order to meet the demand because it's hot and because there is such a huge demand for air conditioning. So you can see this is why at the end of the day we end up with peak demand costing us, and I'll just label this would be peak demand. Peak demand costs us the most simply because every time we end up demanding more electricity, we've got to bring on more costly ways of providing it. Now, what's amazing about solar and other forms of renewables, but particularly solar, is that solar is providing energy during the times of peak demand. I'll just draw a little line here. Solar is really producing most of its energy between 9 a.m. and 3 a.m. And so when we look at, gee, well, solar kind of fits really nicely into this segment, and it is a renewable form of energy. It's happening every day in real time. You can see why we would want to incentivize for this technology. And even though it may be expensive right now in terms of it's got to be incentivized to make sense for us, that is, it's greater than $1 per watt of installed cost. But because it is still prices come down quite dramatically, but because it is still over $1 a watt of installed cost, it still needs to be incentivized in greater than 75% of the U.S. in order for solar to really make sense in the U.S. And so, again, just a quick recap. The real struggle we have is that we have this area here of peak demand. We know we're going to need base load and medium demand, but it's times of peak demand here where we really get into trouble. That is, it costs us the most right here at peak, where electricity can cost upwards of 27 cents per kilowatt hour if we're looking at the wholesale rate of electricity. We've got base load being supplied largely by coal and natural gas, and we've got our medium level also being supplied by coal, natural gas, and other forms of electricity too, such as nuclear and hydro. But it's really the peak demand here that ends up costing the most, and that is why it's expensive.